Hello, just a quick note about how to find the turning point of a parabola. I've just given an example of a parabola up here, and I'm going to quickly talk through 4 different ways that you can find either the turning point or at least the x-coordinate of the turning point. So the first approach, which I think is often the fastest, is to use this formula. The x-coordinate of a turning point, given that your quadratic function looks like that, the x-coordinate of the turning point will be negative b over 2a. So in this case, it would be negative 5 over 2 times 2, and that would give you the x-coordinate of the turning point. And then, of course, to find the y-coordinate, you would just substitute that x value in here, right? And you would get your y value. So that's approach number 1. Number 2, you could find the x-intercepts, or maybe sometimes they'll be given to you. And so if you have the x-intercepts, what you can then do is you can find the x value that is halfway through them. It doesn't make sense. So if your x-intercept is 1 and your other x-intercept is 5, right, the number that's right in between 1 and 5 is, well, right in the middle of 1 and 5 is 3. So that would be the x-coordinate of your turning point, because your turning point lies on the parabola's axis of symmetry. So that's another way that you could find the x-coordinate, and then as with the previous method, you would then put that x value into the function to find the y-coordinate. Right. Approach number 3 is to complete the square. The nice thing with this approach is that it will give you both the x and the y coordinate straight away, but obviously it's a bit more of an involved process. So what you would need to do is you would need to, for instance, rewrite this in completed square form, right, so that it looks like that, because then you know that the x-coordinate of your turning point will be negative p, right? So if this turned out to be x plus 1 squared, then your x-coordinate for your turning point would be negative 1, and this would be your y-coordinate. So your turning point would be negative p and q. And then the last method you can use is you can find the first derivative of your quadratic function, right? Find your first derivative, in this case 4x plus 5, equate that to 0, find the x value that solves this equation, and that will then give you the x-coordinate of the turning point. And this is, of course, because the first derivative, that function talks about the gradient of f, right? And the turning point occurs when the gradient is 0. So that's why we're solving this equation. Once we find the x value that solves it, we have then found the x-coordinate for the turning point.